Okay, so let's now, to get to a trig function of any, a trig value of any function, let's talk about what we really mean by a reference angle. Talked a little bit about it in the last video. So by definition, if we let theta be a non-acute, okay, so non-acute, any angle that is not between 0 and 90, angle in standard position, we learned in the first video what it means to put an angle in standard position, that lies in a quadrant. So meaning it's not a quadrant angle. It doesn't lie directly on the X or Y axis. It lies somewhere in between. Okay, its reference angle is the positive acute angle we call it theta prime, formed by the terminal side and x-axis. So let's jump to an example. And we'll get started. We'll immediately take a look at examples in degrees first, because I think you understand degrees a little better. Let's suppose I had an angle that was 120 degrees. We all know how to put that particular angle in standard form. Okay? So starting on the x-axis, right, there's your initial side of your angle. We are going to move, well, that gets me to 90. If I kept going all the way to the x-axis, negative x-axis, it would be too much. It would be 180. So 120 is somewhere here. You just have to estimate it. Boom. And I'd say, okay, that's about 120 degrees. So according to definition, the reference angle, theta prime, is formed by the terminal side, which is right here. It's this one right. There is the terminal. And x-axis. So it's right here. What we need to do is we can get the degree for that reference angle. So if theta is 120 degrees, and we know the straight line, of course, is a 180 degrees, we would have to do 180 minus 120, and we can determine that this is a 60-degree angle. So in other words, if theta is 120, the reference angle would have to be 180 minus 120, which is 60 degrees. That only occurs because this angle happens to fall in quadrant 2. And for any angle that falls in quadrant 2, you can find the reference angle by subtracting 180. Okay? That's if your original angle is between 90 and 180 degrees. Let's take a look at another one. Let's look at one that falls in quadrant 3. And this time I'll go on to pi's. Because one of the things you're going to have to get really good at is working with angles in radians. So for this particular one, I am going to take the angle theta is 7 pi over 6. All right. Well, to work with your radians, you know this is pi over 2, that's pi, that's 3 pi over 2, and that's 0 and 2 pi. One of the things you want to really probably get in the habit of doing is being able to add and subtract pi from an angle. So 7 pi over 6, if I'm trying to figure out where that falls, well, 6 pi over 6 is the same as pi. So 6 pi over 6 falls directly where pi is. So 7 pi is going to be a little bit beyond that, right? This is pi, which is equivalent to 6 pi over 6. So to get to 7 pi over 6, I'm going to go a little bit more than that. How do I figure that out? Well, I would need to take my 7 pi over 6 and subtract a full pi. Well, 7 pi over 6, a full pi is the same as 6 pi over 6, gives me pi over 6. My reference angle equals pi over 6. So again, adding and subtracting pi or 2 pi is something you will get very used to. Let's try another one. Let's look at one in quadrant 4. So now theta equals 11 pi over 12. No, not 11 pi over 12. Let's do let's do 11 pi over 6. I was trying to think of a different example. We'll just do this one for now. Sorry. 11 pi over 6. So if you were doing 11 pi over 6, well, we know 6 pi over 6 gets us to here, right? 11 pi over 6 is really close to 12 pi over 6. 12 pi over 6 gets us all the way around. 11 pi over 6 is going to be just short of that. So that's how you want to think about it. 11 pi over 6, well, to get theta prime, I would have to take 2 pi minus 11 pi over 6. Well, 2 pi is 12 pi over 6 minus 11 pi over 6, so that's again pi over 6. Has a pi over 6 reference angle in quadrant 4. Again, you're going to want to practice all of these angles and working with pi. How did I know it fell in quadrant 4? Well, 11/6 is definitely greater than 3 halves. Because if I make equivalent fractions, 3 halves is 9/6. 11/6 is definitely bigger than 9/6. So I knew it was past pi, because that would be 6 pi over 6. 3 pi over 2 would be 9 pi over 6. It was past that, but it was less than 12 pi over 6. So if you're dealing with angles over 6, you almost want to convert everything else to over 6, and it makes it a lot easier to work with. All right, so how do these reference angles help us? Suppose I wanted tan of 5 pi over 4. And I want you to find the exact value. Well, here's the problem. You cannot plug it into a calculator and get an exact value. If you plug it into a calculator, what you're going to end up with is a decimal approximation. So what do? First thing we do, sketch it. Where does 5 pi over 4 fall? So again, here's how you want to think about it. Well, 4 pi over 4 is a full pi. That's over here. 5 pi over 4 is slightly more than that. In fact, how much more? What is the difference? Here's your reference angle between the x-axis and that terminal side. Well, it's going to be 5 pi over 4 minus, right? We're left with pi over 4. So it's simply a pi over 4 extra. So this equals pi over 4. Well, pi over 4. We know something about angles that are pi over 4. Remember these triangles I told you to remember? The pi over 4 triangle looked like this. We're going to use that. You're going to take where the terminal side of that angle is. That is going to become your hypotenuse. Drop a right perpendicular line, a right angle to the x-axis. And you're going to take this information where you know the pi over 4 isosceles right triangle has sides 1 and hypotenuse square root of 2. Put it in here, knowing that your radius, that your hypotenuse must always be positive. Always leave hypotenuse. Fill in the correct negative signs depending on the quadrant you're in. So what does that mean? Well, let's look at this one right here. Well, that has to be negative. I'm in quadrant 3. They're both negative. Fill in those negative values. It will help you now knowing that the tan of our angle equals 5. Sorry. Forget I did that. Knowing that we want the tan of 5 pi over 4, you can go to this triangle now. We know that tangent, and you can use either one. You can use the fact that you know it's y over r, or you can just simply use that you know it's opposite over adjacent, not y over r, sorry, y over x, or opposite over adjacent. So opposite over adjacent, it's always easier, I think, to go in that direction. Draw it. Oh, it's negative 1 over negative 1. Positive 1. But I can come up with any of them. Maybe I asked for the sine of 5 pi over 4. Well, the sine of 5 pi over 4 would be negative 1, which is opposite side, over square root of 2, which is negative radical 2 over 2. So we can draw our angle and get any trig function we want once we have an appropriate right triangle drawn from our reference angle. Let's do a few more of these. Let's do cosine of 4 pi over 3. All right, where's 4 pi over 3? Nope, 4 pi over 3. 3 pi over 3 gets me to here because that's just pi. 4 pi over 3 is a little bit beyond that. So this is 4 pi over 3. And how much over? Well, it's another pi over 3. So my theta prime equals pi over 3. Okay, so what does that tell me? It tells me I'm using this 1, 2, radical 3. So shortest side of this particular triangle is a 1. Hypotenuse is double that, and radical 3 for the bottom leg. 1 is your shortest side across from pi over 6, which is 30 degrees. And then square root of 3 is larger. It's across from pi over 3, which is equivalent of 60 degrees. Again, you need to memorize this. What does that tell me? I can draw my triangle now from pi over 3, reference angle pi over 3, in the third quadrant. Here's my angle pi over 3. Adjacent to pi over 3 is a 1. Across from pi over 3 is square root of 3. Hypotenuse is 2. Don't forget your negatives. Because we're in quadrant 3, those are negative. From there, you can find every single trig function. We just want cosine right now. Cosine of 4 pi over 3 then. Just go from the angle, the reference angle. Cosine is adjacent over hypotenuse, negative 1/2. So if you draw the triangle correctly, you can get anything. Let's do another one. Let's do sine 5 pi over 6. Sine of 5 pi over 6. Okay, 6 pi over 6 gets me to here. 5 pi over 6 is just short of that. In fact, how much? It is exactly pi over 6 short of that. So my reference angle is pi over 6. I can use this same triangle that I used in the last one, but now I want to go from pi over 6. So when I draw my triangle, I'm going to drop it down to the x-axis. Across from pi over 6 is the number 1. Adjacent is square root of 3. And the hypotenuse is 2. Fill in the appropriate negative values. That square root of 3, because it's along the negative x, is negative, but the 1 is a positive. It's going up the positive y-axis. Okay. Sine 5 pi over 6 is going to look like, well, it's opposite over adjacent, simply 1/2. Done. So, by drawing an angle in standard form, determining that angle's reference angle, knowing your standard trig functions, you can get exact values. But we can also do this suppose we were given that the sine of theta equals 3/5, and theta is greater than pi over 2, but less than pi. Can we find cosine of theta? What do you think? If you're not sure what to do, always draw. What am I drawing? Well, sine theta is positive 3/5. That means this angle theta falls somewhere in quadrant 1 or 2 because they are the only two quadrants that sine is positive. This information here narrows it down further to, it's between pi over 2 and pi. Now I know I'm in quadrant 2. I don't know what theta is, but we don't need to know what theta is. We're just going to draw an angle that falls in quadrant 2. There we go. Drew it. There's my theta. Boom. There's my theta prime. I have an angle that's drawn in quadrant 2. Well, what other information do I have about this particular angle? I know the sine is 3/5. So if I turn it into a right triangle by dropping to the x-axis, sine is opposite over hypotenuse. That's 3/5. Well, I have a lot of information now. I still don't know what theta is, but that's okay. I want cosine, but cosine is adjacent over hypotenuse, so what do I need? I need this x value. How am I going to get that? I've got a right triangle. We know 3 squared plus x squared equals 5 squared. Leg squared equals the hypotenuse squared, so 9 plus x squared equals 25, x squared equals 16, x equals 4. All right. But I got to look very carefully. I now know the length is 4. But look at what quadrant you are in. Because you are in quadrant 2 and 4 is an x value, all x values in quadrant 2 are negative. So now when I figure out cosine of that theta, answer -4/5. I was able to do that without ever determining what theta actually was. But I now know that the cosine of it is -4/5. All right. There's a lot of problems in your math lab. To practice, you can also go to your digital textbook on page 548 if you choose to practice the odd numbers. All of them are worked out for you in the student solution manual, which you can also access in Math Lab. But I strongly suggest you practice a lot of these problems. All right, I'll make one more short video in this section, or yeah, I'll make one more short video on using a calculator. When you are allowed to just give approximate answers.